Hi all, this is the badging video for the magnetic brake here at MakeHaven. So this is a fairly simple machine. The idea is that it bends sheet metal. This is called a box or a finger or a pan brake, and it's similar to a press brake like the little one we have over here, except the idea is that it can go past 90 degrees and it can do some shapes that the press brake would have a harder time doing. This one is magnetic, and what that means is that the fingers, these top pieces, are held down with a magnet. So the metal that you bend does not need to be ferromagnetic, it just needs to be thin enough so that the magnet can hold on to the fingers on top of it, clamp it down, and then get bent around those fingers. The reason it can be called a box or a pan brake is because it can be used to fold sheet metal into boxes or pans. I'll show some pictures of what that looks like and how that can be done. And in fact, there's a special set of fingers right over here for that purpose, that long one with the slots in it. Some basic safety stuff for this tool is that it squeezes these fingers to the bed very, very strongly with thousands of pounds of force. So you really don't want any body part between there when the magnet is on or off. Another thing is these fingers are pretty heavy, so be mindful when you're carrying them not to drop them. And not a bad idea to wear steel-toed shoes or put on steel-toed booties to protect your feet in case you drop something. Another thing to note is that this generates a very powerful electromagnetic field. So if you have a pacemaker or other electronic devices on your body that are sensitive and important for your health, I would recommend probably not using this tool. The manual says to stay about 12 inches away from it, I think. So in terms of what kind of materials you can bend on here, the limits of the thickness, so the thickest metals that you can do are 12 gauge aluminum. So 12 gauge aluminum is about 0.08 inches. 16 gauge mild steel, 0.06 inches, or 20 gauge stainless steel, 0.036 inches. Anything thicker than that, and when you go to bend it, these fingers will probably pop off. They won't be able to hold the material down. Obviously, those numbers are a little bit rough because it depends on the temper of the metals, particular alloy, etc. You're welcome to try thicker things, but the fingers might just pop off and not be able to hold it down and bend it successfully. So we're going to look over here at the controls for this machine. Over here, we have the power button on the right. Then it says clamping for bending or continuous light clamping. Effectively, this is just depending on how thick your material is. So for thicker things, you want to set it to clamping for bending, and for thinner things, continuous light clamping. Start activates the magnet, stop turns it off, and then this light just lets you know when the magnet is on, which is very important because you don't want to be moving these around or even bringing anything metal near the top of this that your fingers might be under when that electromagnet is on. There is also a start button over here on that side. Up here, you'll see that some of the fingers have these knobs, and what these are for is to set the gap. So here you can see there's a little gap between this blue finger and the edge of the bed. And in theory, that's a little more than the thickness of the metal that you're bending, so there's room for it to bend up. So I'm just gonna lift this so you can see what that would look like. So when you bend this up, you need there to be a little room there for your metal to exist in. And so 2 is more, 0 is less, and 1 is in the middle. So you just adjust that based on the thickness of your material. Here we see a bunch of different finger options that you can use depending on the size of bend that you're trying to make or the size of the material. The longer the finger you use, the more meat there is for this magnet to pull down on. So in general, you want to use the longest piece of finger that you can. Down here you can see this is the arm that the leaf is connected to, And this slides on here, and you can see on here that there is this scale with the degrees of the bend. The top of this collar is the degree that you've bent it to. So when we go to 90, so this is now straight up and down, you'll see that the collar is right at 90. And the reason for that is you can lock this collar for repeat bends so that you can just lift the leaf and it'll stop right at that collar. Keep in mind that most metals have some amount of spring back, so you'll actually want to bend a little bit further so that when you let go and the material springs back, it'll end up at the angle that you want. So if you figure out what that angle is, that overbending that you need to do for your particular material, then you can just set the collar there and do those repeat bends and not need to figure that out every time. We have something similar on the back. Over here we have these collars, and these are just stops you can put on here, and you can see they're sort of eccentric. So that top is thicker, so you just lock it there, and then your sheet metal would butt up against here so that you can do repeat bends at the same distance from the leaf every time. Here you can see 3 different pieces of metal that I grabbed from the scrap pile, and I'm going to use these dial calipers to measure their thickness and see if they'd be appropriate for bending on here. So first we have on the left a piece of mild steel, galvanized mild steel, and it was cut on the water jet, so it has a little burr here, so I'm just going to measure past that burr. And we can see that it has a thickness of about 0.037 inches, and that's good for mild steel because the max thickness for mild steel is 0.06 or 1/16 of an inch. So for the aluminum, we're going to measure it, and that measures at 0.065, and that's okay for aluminum because the max thickness for aluminum is 0.08 inches. And then over here we have stainless steel, and when I measure this, it measures 0.078, and that's too thick because the max thickness for stainless steel is 0.036. So this machine probably won't be able to bend that stainless. Now, if you were just doing a narrow strip of it, for example, if you just wanted to bend like a strip this wide and you used a wide finger, the machine might be able to do that because it'd have a lot of material to hold down on that big finger, but only be bending a narrow thickness or narrow width of this material. So it's not a hard rule. And luckily you won't damage the machine if you try to bend something too thick. You just won't get a good bend. So we'll take this one out of the pile and we'll bend these two. So first we're gonna make sure that the number that this is set to, that gap that it has, is appropriate for this thickness of material. Let me show you exactly how this width setting works. So underneath here, you can see that ball bearing, and it rests in this groove. So you need to make sure when you put the finger down that that ball bearing is resting in the groove. It also keeps this finger above the bed, so you can easily slide your material underneath it, which is pretty convenient. Then when the magnet activates, it pulls the finger down to the bed. These ball bearings are spring loaded, very powerful spring. I actually can't push that with my finger, but the magnet can depress that spring and pull the metal down flat to the bed. Not all the fingers have that. That's just for the full length finger here and for that full length finger there. These smaller pieces don't reach the edges, so you just need to align them manually. So I'm gonna fold this back down, and we're gonna make sure that the ball bearings are resting in the grooves. Okay. Now that the leaf is lifted up, I can take this piece of aluminum and put it in the gap and see that it fits nicely on that number 1 setting right in there with a little bit of extra wiggle room. When you bend a piece of metal, it doesn't make a perfectly sharp bend. There's a little bit of radius on the inside, so you need a little gap there for that radius to sit in. If it was thicker, then we can change this to 2, and you can see now there's a wider gap. Or if the metal was thinner, you can move that to 0. Now it's clamping it tightly. So we'll leave it at 1 and make sure that the other side is at 1 as well. I'm going to lower the leaf. Now, we'll just pretend that I want to bend it right along this line here because those are easy marks. But in general, you should put marks on your material for where you want to bend it. If you've cut it out on the water jet, you can use the scoring setting on the water jet, which will leave marks in the metal, but not cut it. But those are helpful references for bending lines. Another thing to note is that you want this finger to stay flat. And so you need at least 2 inches of metal underneath this finger. So if you're doing something smaller, let's say you wanted to bend this along this line, you wouldn't get 2 inches underneath there. And then what would happen is that leaf would be cantilevered up and it wouldn't have nice firm engagement with the magnet underneath it. So what you would need to do is put something underneath the back edge of the same thickness so that the finger stays flat on top and doesn't cantilever up like that. So that's how you would address that situation of bending narrow things, is putting a strip to support the backside. But this goes fully through, so it's fully supported. And I'm doing it somewhere in the middle of the brake. It doesn't need to be perfect. Then down here, we're gonna push the on switch, and we're just gonna leave it in clamping for bending. And now I'll push start and you can see what happens up here. So this just got sucked down to the bed. And up here, it's actually still high. So what we could do is move our piece of metal closer to the middle so it's more balanced. So let me do that. And when you depower the machine, when you turn off the magnet, you actually need to hold this for about 3 seconds. And that puts a reverse magnetic field through the finger, which demagnetizes it. So in the process of holding it down, it actually induces a magnetic field into this piece of metal, which keeps it magnetized. And so to undo that so it fully releases, you need to hold this for about 2 to 3 seconds. So that's why it stayed clamped until I held that and then it released it. So now we can slide this over to the middle, like that. And now we'll see if it clamps more evenly. So you could see there that I actually manually pushed it down on this side just by pushing down, and now it's clamped at that side and at that side. I'm not really sure how much that would matter. I think the bend would probably come out fine either way. All right, so now we just lift the leaf. And over here we can see the angle. So let's just say we're going for 90. So let's say I just hit 90. That. Aluminum doesn't have much spring back, but you can see that it isn't quite 90. It's still a little shy of 90. So you would need to go a little further to get there. You might also be able to hear that when I pull back on this, another magnet engages. So it uses the lighter clamping force when the material is just clamped down, but when you actually start to bend, that's when it engages the full magnet. So here, we went to like 92, maybe, yeah, I think that's like 93. And that looks pretty close to 90. So we can measure that to make sure, but now we know that for this alloy of aluminum, at this thickness, at this temper, 93 degrees is what you need to get to 90. So you just set that collar to 93 and know that every time you get what you're looking for. So now we're gonna push the stop button and see it's still clamped down. So we actually need to hold it. 1, 2, 3. Now it's demagnetized. That's also a safety thing because let's say it did pop up, but you still hadn't actually held it for those 3 seconds. This piece of metal would still be trying to get to this piece. So then if you were able to lift it up and get your fingers under there, it would still be trying to clamp your fingers down. But now it's safely demagnetized. It's not trying to stick to the table anymore. So here we can see our nice crisp bend. That looks great. Some alloys of aluminum don't like to be bent. So for example, 6061 is pretty brittle. And so if you tried to do this without tempering it, it would just crack. So that's something to bear in mind. 3 other things to note are, 1, that you don't want to drop this leaf. So this guy down here, just let it down nice and slowly. You don't want to drop it. If you drop it, it can break the switch that's in there. And slamming these pieces of metal can also mess with their magnetic alignment, according to the manual. So make sure not to drop any of these things. Be nice and gentle with them where you can. 2 is this uses a lot of electricity. So if you start to feel it getting hot, make sure to turn it off and let it cool down for a bit. So you'll damage the magnets if you let it get too hot by running it for too long. And then last, try not to turn the magnet on without any material in there. The machine at that point will have a lot of electricity flowing through it to make that magnetic field holding this thing down without any distance between the bed and the finger. So bear those things in mind. Don't clamp without material in there, stop if it gets hot, and don't drop any of the metal pieces, including the leaf. So we'll swap out the big finger and try one of these smaller ones just to try something different for a piece of steel. So what I'm going to demonstrate here is how you might use this to make a box. So we're going to do 2 subsequent bends so you can see how that would work. So without the knobs on the ends, I'm just manually setting a gap at this edge here to make sure there's enough room for that bend to happen. Then I'm going to activate the magnet and then bend it up. And because this is steel, I had to account for a little more spring back. So now I'm pushing the off button and holding it for 3 seconds. And now we got a little finger in there. So now I'm going to turn the magnet on again. Lift up. And now you can see we've made this cool boxy shape. Just like that. If you, let's say you had 2 sides on here, so you had 1, 2, you could either put fingers inside of there and then remove them afterwards. And then an alternative that works sometimes is to use that longer finger with slots at various intervals. So that gives you maximum clamping power, but also slots for the sides of your pan to come up into. One last thing is that this tool is on wheels. So if you want to use the wheels, you just lift these feet and it lowers it down onto them, one on each side. So you can kind of roll it to get yourself a little more room if you need it. In general, we'll just leave it like that though. When you're done, obviously make sure to turn this off and throw away any scrap and other bits and pieces, trash, wipe it off. Please, try not to get anything on here, but if you do get any grease or whatever on there, just make sure to wipe it off so it stays nice for a long time to come. Thanks for watching.